Hello everyone, Harsh Verma this side, and we are continuing our series on Network Warrior, and we have been going through the protocol, routing information protocol. For those who don't know about the series, actually we are going through this book called Network Warrior, which is a book by Gary Dono, and this book specifically targets the concept that we usually tend to miss while preparing for and after the CCNA examination. So it is very helpful in respect if you are preparing for CCNP or have want a deeper understanding of the things how things actually work. For example, in my last read that I was reading yesterday, I tend to know the multiple types of card used in chassis switches. For example, there's a line card, there's a supervisor card, etc. So topic for the day is not about the hardware related switching side of things. We will cover in this same series in future video, but topic for the day is routing information protocol. So without any further delay, let SSH into my phone and read the notes aloud out aloud. So notes where will be? It will be in terminal. Where is terminal? Here it is. Okay, so the routing for information protocol, we cover kind of in brief and in much detail what routing protocol RIP is, and there are different versions of RIP, which is RIP version 1, RIP version 2, even RIP NG, which stands for RIP next generation, with support for IPv6 addresses. We have already covered what route poisoning is, reverse poisoning is, because RIP is a distance vector protocol. The terminology route poisoning, reverse poisoning, as well as a split horizons applies to the same protocol. So we are just going one step ahead in understanding RIP. It is basically an outline, and I cannot for sure say that these things are not studied in CCNA, but certainly these things has to be kept in mind and needed to be revised. So just a little bit handshake from my end, and I hope you will do with the same to the RIP. So the RIP uses broadcast and it broadcasts all its route it knows every 30 seconds. While RIP version 2 uses multicast and multicast address is 224.0.0.9 to share updates. So this line clarifies that RIP version 1 tends to share all its update at every 30 seconds at its broadcast network, and in broadcast network all devices are going to listen the updates. So it's a kind of inefficient approach by RIP version 1 that despite having no changes in the database, it definitely shares it to its broadcast address. While RIP version 2 is kind of have a efficient and smarter approach because multi-address is a specific address that is assigned to a protocol in which only routers or only devices running that protocol listens to that particular address. So it saves some CPU cycles or the ASIC cycles of processing on the device's end. So it uses the address that I just told you, 224.0.0.9. RIP does not use triggered update. And yes, this is the update. Triggering means to having a change in their respective databases. I have just told you, or I've told you in the last video, that every routing protocol tend to maintain their own databases. OSPF maintains its databases. EIGRP maintains its adjacency tables. OS or I meant to say that even BGP tends to maintain its local RIB and what was it? Let me go through that in a quick moment. Mm, a protocol or table maintained by BGP. Yes, adjacency RIP. This is it. Adjacency table, adjacent routing information basis, routing information base. I guess, yes. So make sure to go through the last 2 or 3 videos in which we have discovered or studied it. Actually, it's 4 video right now. Okay, so continuing the same, while RIP version 2 does only shares the triggered things. For example, the changes when a database gets updated, only then the information is passed to that multicast address. While RIP is being inefficient, does every 30 seconds, no matter whether the things have been changed or not. Okay, the next thing is RIP only understand classful subnets and host network. By meaning classful subnet, we have understood what a classful network is. Basically, network is divided into 5 classes. IPv4 network is divided into 5 classes. Uh, IPv6 is divided into multiple different kinds of classes. There's a link locally, but that requires a separate video of its own. So talking about the IPv4, if there's a class A, class B, class C, class D, and class E. We do not tend to use the class D and E because D contains the network that is used for multicasting, while the class E is experimental series. We only use the class A, B, or C networks. Okay. So RIP when it shares the update, no matter where the sub network the route belongs to, it only shares the prefix of the class itself. For example, the class A is /16 prefix, or class B has /24. You have to actually go through its via a quick online search. But I'm just saying that RIP uses the class full techniques and only understand the classful sharings, while RIP2 understand the CIDR notations and VLSM. The CIDR, which stands for classless inter-domain routing, and VLSM, variable length subnet mask, is nothing but a variable prefix which ranges from 0 to /32 or up to 32. 32 understands that it's a host only IP address, while 0 stands the default gateway. So RIP version 2 shares all of them. Next is passive interface command causes RIP to stop sending update on a specified interface when ran in interface configuration mode. So there's a command, for example, we don't want to share routes on a particular device. And why we do that? Suppose we have a router, we have a scenario in which the router is connected to some endpoint devices. We are not using switch, or we may be using an unmanaged simple switch which simply terminates to its endpoint. So we don't want to share a route over there because there's no other router to listen to that. So we can issue the passive interface command on that particular interface in order to disable the route sharing over that interface. Finally, the next thing is redistribute connected. In RIP tells that the router to advertise the route for the interfaces that have an IP address assigned a directly connected route into RIP routing. This concept regarding the route distribution. So route redistribution means when we run a protocol and we also use some static IP addresses. So we have to tell the protocol to advertise those IP addresses into its own routing domain. So that address can also be shared to another router. So another router can reach that address using the hops in between and finally through that router. Okay, so we in order to do that, we use the command called redistribute connected. And for the final and last line for today's video, because I know today's video being the smallest of its class, so it is the IP version 1 always auto summarize, and this auto summary cannot be disabled. While we do have an no auto summary command only for route version 2. So basically, this video is all about the distinction between RIP and RIP version 2. And as I already told you that RIP-NG is basically the RIP version 2, but for IPv6 support, but with IPv6 support. Okay, so what does auto summarize mean? Studied in previous video that what a route summarization is. Basically, it is kind of supernating the routes. For example, there's a multiple subnets here. So what it does in order to make shrink the size of the update, it automatically supernates the different subnets. So it simply announces that I have access to all these following subnets into a single network address. So that is it. So RIP always does that in order to be efficient because it's already very inefficient in terms of route sharing and broadcasting. And it also does this. And this behavior cannot be changed in version 1. So luckily we got the version 2 that has the command no auto summary. And we can disable this feature, you can say, or the problem, you can also say that. So this is for this video. So as you can see for the topic, we will going to study the EIGRP in the next this kind of video. It will also be just like a basic comparison, basic feature sets, and most likely it will be discussed already in previous video. But for the goodness sake, please watch the following videos. It will help you in your career, in your network journey, in your academics, etc. Whatever you are going up to. Okay. So thank you very much. Thank you for watching. Thank you for liking and thank you for sharing.